All right, welcome back. Here we are at 12.5. Going to be kind of talking a little bit about infinite geometric series. Again, geometric meaning we're multiplying. And again, we know it's getting bigger if we're multiplying by a number bigger than 1. If it is a number between 0 and 1, it doesn't matter if it's positive or negative, really. But if it's between 0 and 1, then we know it's getting smaller. So we're going to talk about how that works. And you can kind of see the different graphs as we looked at the one on the left. We can see that we are multiplying by a number less than 1 because it's getting smaller. I mean, it's kind of increasing to getting to a kind of a limit, whereas this one here, you're not. It's going to grow indefinitely. And so we always say it converges. It's going to get to a limit is what's going to happen as you multiply by a particular number. It's going to end up as the sum. Anyway, it gets there. You're going to see it get to a limit. So converge means that it goes to a point. Diverge means it keeps getting bigger and bigger. And when that ratio is bigger than 1, whether it's positive or negative, doesn't matter, it is said to diverge, in which case we can't really sum it up. But if it gets smaller and smaller, eventually it'll get to a limit, and we'll be able to sum those up. And we'll get a formula here in a couple slides here just to see how that works. So the first thing is being able to identify whether it converges or diverges. And letter A here, you can see 10, 1, 0.1. It's getting smaller. So we know that it converges. What you're multiplying by is 0.1. And you can always take the number and divide it by the previous number in order to figure out what that ratio is. And that's going to be something down the road we're going to want to do. Now, as we look at B over here, we know so we have 4, 12, 36. Well, we're multiplying by 3, so it's getting bigger. We would say that series diverges, gets bigger and bigger. Okay, so the question might be, well, if it converges, how do we find the sum that it goes to? Well, here it is. There's the formula right here. Now remember, it has to be a converging series, otherwise you can't find the sum. If it keeps getting bigger and bigger, you can't add that up. But what you're going to do is you're going to take the first term, and you divide it by 1 minus whatever your ratio is. So whatever you're multiplying by, and that number should be a number that is between 0 and 1, should be less than 1 is what it should be. So there we go. So just a couple ways to do that. You might see something like this. Obviously, this is getting smaller. The ratio, if we take negative 0.2 divided by 1, we would see that the ratio is negative 0.2. So using the formula, the first term is 1. So we put that up top, and then on the bottom we put 1 minus. Now it is a negative ratio, so we'll have negative 0.2, in which case 1 divided by 1.2 is 0.83 repeating is what that is if you add up all those numbers. Okay, so yeah, that's the formula. Now again, as we had the other sum from previous sections, we could say, oh, maybe you could write them all out and add them up the brute force. Well, since this is infinite, yeah, you can't really keep going forever and ever and add them up. So you kind of have to use that formula that we have here. So going back to this slide, or going to write that down, that's kind of a key thing to be able to do. It's actually pretty easy. All right, so what if we get it in summation notation? Now we're saying we're going from 1 to infinity, indicating that it is an infinite series. Well, whenever we do this geometrically, we know that the base of the exponent, that's going to be our ratio. That's going to be 1/2 right there. Now, again, you can always put this in the calculator in the table mode and kind of see what the numbers are. But really, all you have to do is put the first number in, put the 1 in. That's a 0. Well, anything to the 0 power is 1. So all you need is that first term, and you need the ratio. Well, we have those two things. So once again, put a 1 up top. Go 1 minus 1/2. Well, the sum would be 2. It would be 2 is what we have there. All right, so there we go. Always make sure now, if this base of the exponent, if that's bigger than 1, you can't do it, right? Because that's a diverging series. You got to be careful on those. Pay attention to that. All right, another little trick thing we're going to show you today is how do you take a repeating decimal and write it as a fraction? Good call, good call. Now pay attention to what the line is over. If it's over the 6 and the 3, that means it repeats 6, 3, 6, 3, 6, 3. Now if it's just over the 3, only the 3 repeats. So you got to pay attention to that. So here's what you do on the calculator right over here. We see we're just going to type this in, 0.63. And what we're going to do is just kind of keep going, 6, 3, 6, 3. We're going to kind of fill up that whole first line with that. Well, obviously you got to stop at some point, but fill up that whole top line, 6, 3, 6, 3, 6, 3. Okay, all right, we got it. Okay, so now what we do is hit enter, and then what we're going to do is we're going to take this and we're going to put math. We're going to go over and we see how it says fraction, and we kind of put this in here. Look at that. It automatically turns it to a fraction, 7 over 11 is what that is. 7/11 is the fraction. Pretty slick. Yeah, that's a great way to do that. All right, let's try that again with another one. What if it's just 0.111 repeating? Well, same thing. Just go 0.11111. Fill up that whole top line. All right, there it is. Yeah, you see how that works. So we're going to fill that in. All right, go ahead and hit enter. And now again, we hit the math button. It's already set up for fraction. Fraction, go ahead and hit that. Enter again. Oh, 1/9, yeah. By the way, if you ever see just a number repeated, like 0.1 or repeated, you know it's 1/9. So if it's 0.2 repeated, it's 2/9. And if it's 0.3, yeah, we know if that's 3/9 or 1/3. It's kind of funny how that works out with those repeating things. So that's kind of a way to take a repeating decimal and turn it into a fraction. Pretty slick. All right, and then one of the last things we want to talk about today over here, we don't need that calculator anymore, is that we're going to identify counterexamples where you think something may be true, but all you have to do is find one example where it doesn't work, okay? So is a to the third bigger than a squared? Well, it kind of makes sense if you go 2 to the third power. All right, we get that. We get 8, and then if we go 2 squared, well, that's 4. So intuitively, you might be saying, all right, that seems right. Well, think of some numbers, that you could have here. Well, you could always put 0, because 0 cubed is the same as 0 squared, so it's not actually greater than. You might actually do like a negative number. Negative 1 cubed is negative 1, and negative 1 squared is 1, and that's not greater than. So a good piece of advice when you're looking for a counterexample is to always try to find numbers like 1, 0, negative numbers, fractions. Those are usually where your exceptions are. All right. Well, I hope you're all doing well. Again, keep up to date on assessments. Email me if you ever have any questions. That's it for 12.5. So we'll wrap this up, and we'll have the Chapter 12 test should be following here shortly. So good luck on this. Make sure to complete the worksheet. And again, if you have any questions, email me. For now, I'm Mr. Boone.